I'm with the White House Office of Science and Technology Policy.
And you all know who I am, I believe, by this point. Okay, so we're going to have a series of presentations, and I believe they are in this order. So please let me know if you think it's different. Tim Walsh is first, right? Okay, then Casey Wang, right? And then Mark Allman. This is session 1, is that right? Maybe Mark's not here. Session 2, we've got George Adams. George here? Yep, okay, right, yep. Suman Banerjee. Suman, are you here? He is here. Okay, right, okay, and then Jeff Daly. Everybody okay? Okay, now, so the purpose of them giving the presentations today is to hear the way that the project they have imagined is shaping up. And so what I want to tell you about are the criteria by which we will eventually evaluate these projects if they are submitted to NSF in response to a call for proposals, right? So what I would like is for the audience, after they've presented their project, to make sure that they have covered these criteria, right? So this is like a test. You need to take notes. Okay, how novel is this application or service? Is this really something new that we haven't seen before? Does it require bandwidth? High bandwidth. Does it have to get to gig symmetric right away? But we're pushing in that direction. Okay, third, is it feasible? Can we actually do it in the way that they have structured it? Is it kind of ready to go, right? And I say ready to go because we really would like the projects to get started and be up and running over this next year. Is this application or service beneficial to some segment of society? What are the metrics that they will apply so that we can understand at the end of something like a year or a year and a half that there has actually been benefit to someone? And do they have the right partnership? Okay, so I don't know exactly what the right partnership is for each project, but we're going to hear from them, from each project, who are the people that they think are necessary to be part of it, right? So I imagine you need your application developer, so your idea person, someone who can really make it happen. You probably need to be in a city or a set of cities. Do you have your providers on board? You probably are going to be involved with some kind of anchor institution. You know, if it's public safety, are the police on board? You know, do you have all the relevant players kind of teed up, as you like to say, ready to go for this project? And then who is going to do the evaluation, right? So you really need to have someone who's expert at that, who can really show real scientifically derived evaluation so that it's not just anecdotal and someone could say, oh, well, yeah, but they didn't do this, they didn't do that, and so it doesn't really count, right? So we want these projects to count. We want them to be successful. So we see this as an opportunity to help you make your project successful, right? And I'm hoping that everyone will listen to each of them and then give feedback, right, to the presenters as we go along. Okay, questions before we get started?
When would you be presenting or issuing a call for?
Probably August or September. Mm-hmm. Okay, then without further ado, Nick, did you want to say something? Did you want to add something?
Well, let me just.
Yeah.
Let me just.
Sorry.
I didn't mean to give you I just wanted to say a couple of words and reiterate some of the things that you pointed out this morning, or this afternoon. I think that, you know, one of the things that we are working hard on at OSTP is figuring out the right way of bringing together agencies, the nonprofit community, universities, and the private sector to work on key issues, whether it's broadband or entrepreneurship or veterans issues. The White House has rolled out organizations to bring these different communities together, align them, and to put commitments down on paper to address these needs in the short term. So one of the things that Jim mentioned in the previous session was Startup America, which is what I was working on before USIgnite. And that was really focused on how do we support small businesses across this country? How do we help support the creation of these drivers of innovation and job creation? And I think that what you saw through that process was agencies doing more programs in this area quicker, better than they ever would have done on their own individually. You saw the private sector step up with commitments from organizations like Cisco and HP and Microsoft and others. You saw the nonprofit entities like Case Foundation and Kauffman Foundation stepping in with new programs. And that's really a template, a model for what we're trying to do with USIgnite. Every one of us is working on an individual program that has an amazing impact, either at a regional level or within a given sector. And what we're trying to do is stand on your shoulders, stand on the shoulders of giants, and bring a little bit of cohesion and long-term strategic thinking to how to leverage these things to achieve the goals of USIgnite. And in our mind, that really comes down to addressing the needs and concerns of the communities, many of whom are in this room today. We've heard too many times about next-gen fiber being rolled out and not being leveraged to the extent that it could potentially be. An individual city, whether it's Kansas City, Kansas, in the Google Fiber deployment, or the great work that Jim is doing in Chattanooga, individually, we can't move the market. We can't accelerate the process of generating these next-gen apps and services, these next-gen CPE, which I'm sure we'll all be happy to hear more about. I think that the goals of USIgnite are to bring all these communities together, create that test bed, and then accelerate that process that is going to occur over the next 10 years, but chop it in half. Accelerate that process so that we begin to deploy these applications and have them take hold over the next 3-5 years. So we are doing the same thing today that I was talking about with Startup America. We are working with a half a dozen agencies, with NSF obviously in the lead, talking with Department of Defense and Energy and NIH and HHS and Education. How can we leverage the programs that they have today to accelerate the development and deployment of these applications? We're also working with 20, 30, 40 of the leading technology firms in this country. We're talking to them about their expertise, the capabilities, the equipment that they've got available, and the R&D going on internally within those organizations that we can leverage for this effort. And then finally, we're working with that university community through NSF and Genie and others. How can we leverage the researchers to bring them together with the application developer community, the startup community, to convert these research projects into pre-commercial and then commercial applications? So our goal is to make this a big tent, as Lev called it. Make this as big a tent as possible. We have no sides in the variety of technology wars. We want all sides represented. We want to have a nice, huge party down at the White House in September. We'll invite you all there. I can't guarantee that the food will be as good as what you've gotten here. But that's our goal. September, we bring everyone down. We make some concrete commitments. Here's all the great work that we have been doing over the past year. Here is what we're going to do over the next year. Here's what we're going to do over the next 5. And recognize what we can accomplish together that we couldn't do individually. And so our goal at OSTP, at the White House, at NSF, is to be a coordinator, a convener, helping make connections across all of you and help address any challenges, barriers that you're facing. I mean, that's really what we're doing here is to troubleshoot the challenges that you're facing and rolling out your applications. So we look forward to hearing about these teams and hearing all the great work that they are proposing. This is really where the rubber meets the road. This is exactly how we're going to address the needs of the communities. This is how we're going to create these next-gen applications. This is how we're going to create the next great startup and tech giant in the United States. So let me pause there and
So I just want to add that this is being a webcast, and so each presenter, the default is that it will be webcast, but if you really don't want it to be webcast live, then please let us know, and the operator back there will turn it off for those minutes that you're presenting. Are you okay? Okay. Okay, so let's move to Tim then. 7 to 10.
Let's see. Sure this will be hidden. Oh, that's the way. Audio check.
Hello, can you hear me all right? Thank you very much. This is very exciting for me personally. I've been in the technology world for most of my career and certainly applying applications. Our project here is we're calling it the next generation public safety system or network. I'm Tim Walsh. I'm the president and CEO of Simpson Enterprises. Simpson Enterprises is a not-for-profit public-private entity responsible for commercializing the technology out of the Sim Center. Dr. McDonald, who just introduced himself here a few minutes ago, is the Chair of Excellence at the University of Tennessee for Computational Engineering. Along with Dr. Whitfield, they have over 25 faculty, researchers, and 35 master and PhD students. So it's a very significant capability. They're recognized around the world for computational engineering and doing some incredible work, which you will see here today. In addition, we have strong support from Chattanooga, the foundations, the community. You've all learned a lot about EPB with its 1 gigabit capability. You'll see more of that tonight in the video. What I want to do now is to present to you, and imagine with me, if you will, going into a crisis, catastrophic type of situation. We've all are familiar with this scene here. We can all relate to it. In the last 10 years, we have seen situations where they have been catastrophic and they have totally overcome the first responders and the community. Part of that is not being able to anticipate and understanding the magnitude of these challenges. And number two, having the right tools and capabilities to actually inform the public quickly so that they understand what's going on and then they can also react to that. Today, we have the technology. The challenge is taking the technologies like, let me do this here.
Sorry, the tech folks are on their way, but okay. Just put this way down.
The challenge is that we have all of these capabilities, but we have not deployed them.
hold down the volume on the mixer.
This is not the right mixer for the same, because this is all the way down. These mics.
So I'll back away from the.
I unplugged them all and turned it all the way down. So I'm not. They're sitting somewhere. I'm not. This is my room.
So again, the challenge is clearly not the technology, and now that we have broadband. This particular technology I'm going to show you today, it requires a lot of high-performance computing, and during a catastrophe or in training exercises, we're going to be pushing a lot of data relative to GPS information, not only to provide information about plume dispersion so that we can better direct first responders.
I'm sorry, let's try it. I'm going to pull one of these back and see if we can just use that instead.
Okay.
So actually, can you turn it off inside? Sorry.
We have the technology. We have high-performance computing, and the solutions require high-performance computing. Secondly, we need large bandwidth to push out to the information to the first responders and to the affected community. So we have a solution that is capable of, through the analysis, to provide plume dispersion pathways to help people better understand what the risk is. And we have the capabilities through behavioral modeling and population modeling to actually help send information to citizens in the community to be able to evacuate the situation in a very effective way. What I would like for you to do is to think about this as a total system. We normally hear about the situations where there's a catastrophic event, but we do not really understand all the things that are going on as it relates to that response. In this case, I'm actually using a nuclear power plant. We have been working with folks at the nuclear, with the nuclear operators, NRC, FEMA, and so forth, to talk about what is that whole value chain, to understand where we can actually apply these capabilities, the science, the technology, and how does that benefit the industry and the community. If you look up here in the upper left-hand corner, you will see a nuclear power facility. Whether it be chemical, nuclear, whatever, we have the capabilities through the computational fluid dynamics to model that site. And we can do it in three-dimensional ways. Today, the current technology is two-dimensional, and it's a flat terrain. We can do three-dimensional topologies, buildings, and so forth. Secondly, as a site is being built and they try to evaluate what the impact would be, the risk assessment if there's an incident, the emergency response teams, FEMA, local communities do training exercises and preparation. Through computational fluid dynamics, and the meteorological data, we can run thousands and thousands of simulations. And when we get into training exercises, we can actually provide those simulations to those emergency response people when they're doing those exercises. And as the NRC is calling for in the 2012-2013 timeframe, they want credible scenarios that are time-based dependent, that to help them to understand that this is a real situation and is how we should better respond to it. Thirdly, what happens when you get an incident situation? Here is a real-world modeling of Los Angeles a couple of years ago with an agency. You will see a couple of things here. You will see the plume in red starting to emerge out from the incident. This could be a chemical situation. It could be, God forbid, a dirty bomb. The dots that are moving are cars that are on the major thoroughfares going back and forth, up and down, just so you normally do. You'll see here that the plume is moving in a certain direction. If we play this out over a long period of time, you will see it come down to where it's going to actually come into gridlock. Now, two things are going on with this particular model. Number one, at the Sim Center, they're able to take this topology, this information, understand the source terms, in this case nuclear, and then compute all the various types of scenarios and provide the plume pathway with the current meteorological conditions. Number two, applied agents in Washington, D.C., Alexandria, Virginia. They have developed through agent-based modeling, through demographics, population modeling, and through that modeling, help people to understand, or the emergency operations centers to direct the pathing, if you will, for people to leave or avoid that area. Now, so those two technologies are now real. They're starting to come together. Now, once we get into a situation, and this is the challenge that we have today, and this is where the high-speed Gigabit capabilities, 100 megabyte plus capabilities are very important. Once you're using high performance computing and now that plume is moving out, you're sending out a lot of GPS data. And it can't be done today with the current networks. This is near real time. We have to push that out. Number two, when we start sending information to people over their cell phones, you can imagine when there's an incident, the cell phone goes off. It could be all of us in this room if there was something a few miles away. The alert siren would go off on our phones, and then it would provide us the pathing information to avoid the situation. Also, for those who are not affected, it's important to let them know that they are not in the pathway of danger. So now, we have developed capabilities here at the University of Tennessee to actually start providing pathway information with GIS servers so that we can actually build and test this system. And then finally, what happened in the lower right-hand corner, you see down at the bottom, you're now seeing the deposition. If this is radioactive isotopes, if it happens to be some type of chemical material, the Sim Center, through its computational fluid dynamics, can actually see from that site where it came from with the meteorological conditions and the source terms, can now actually see where these particles, or in case of chemical drops, are actually being deposited. Now you see the results. What does this do? It allows now for the Environmental Protection Agency and other people to come back in and now more intelligently be able to restore that site to a condition where it is now safe so that people can repopulate it, people can get back to work. What's the importance of this? Clearly, it's life-saving, but it's more than just life-saving. It is also helping the people to have a better understanding of the capabilities. It's far more effective. The first responders can feel more confident about going into a situation. They're going into the situation where they're most beneficial. So overall, we have effective emergency management. What's the impact? The impact through this type of capability here is that we now can deploy this technology. We do need Genie. We do need this high bandwidth capability so that when we start setting up our pilots, and we're in discussions already, we're moving forward with actually moving this into a pilot phase with real people and real entities. And finally, the novelty of it. This is a very powerful capability. If we think about what we've gone through in the last 10 years, if we can start standing this up and start being able to provide this type of intelligence, this type of information to the community, then through technology, through high bandwidth, we can help save people's lives, better respond to the situation. Feasibility. We have done a lot of work over the last 2.5 years. We already have done market survey work. We have done a business plan. We're in the process of moving that business plan forward. We have the support and funding from local foundations to get this started. And with that, we will be able to, this summer, we're actually starting to move forward with actually standing this up. We are also talking with other entities. We are talking with people in the Nuclear Regulatory Commission. We're talking with plant operators. We're also talking with areas where the first responders in FEMA have large chemical facilities, and they would like to have a capability like this. Our project would entail essentially building up the cloud-based system, software as a service in Chattanooga, because it is compute intensive, and because of the technologies that's required, we would put this in the cloud and we would make it software as a service. We would then choose 2 pilots. We believe that we have right now targeted 3 to 5 pilots. 2 of the pilots are highly motivated. And then finally, because we're this far down the road, we can immediately start hiring people and start doing the development of this and getting it to work. And then finally, as we go to the end of the next year, as we go through this pilot phase, we would then start taking the pilot prototype and move it into production and take our pilot facilities and actually move them into a production capability. Anchor institutions already in Chattanooga with the city, EPB, the foundations, Nuclear Regulatory Commission, FEMA, and other agencies that we have been talking to are very interested. We have been talking to them now for almost 2 years. City of Chattanooga, EPB, is already there with 1 gigabyte. You'll learn more about that tonight, but that infrastructure is there. They have 2 things for us. One, they have the high-speed internet and the Gigabit. And number two, they have a co-location capability, which is only a few blocks from us, so where you can actually stand up our technology right in their facility. And then finally, we will actually work with other technology partners. We invite them to join with us. We're already working closely with IBM at the Sim Center, but we are inviting people to come forward because we're going to need a lot of help. This whole project and these capabilities with this type of initiative will now allow us to move this into reality far faster than what we were planning with the limited resources that we have today. I want to thank you very much and open it up to questions.
Thank you.
Yes.
Tim, thanks. I was wondering if the algorithms that you're using are proprietary or open. You could sort of share what your thinking is on that.
I'm going to let Dr. McDonald answer that question.
The algorithms are all in the open literature. The computer codes are not, and obviously that's the essential feature. These are huge computer codes, even if they were widely available. It takes a great deal of expertise in order to run them correctly. It takes a great deal of expertise to put the geometries of the and the physical entities, the cities that you're representing. All of that takes a lot of effort, a lot of expertise. Once it's up and running, the access would be software as a service. Cities and city planners, emergency preparedness organizations would be able to access them over the internet and practice and evaluate scenarios and train, and also look at other elements of their emergency preparedness. For example, there are people that are immovable in certain situations, hospitals that require evacuation. The tornado that recently struck Tuscaloosa, one of the elements to go was the hospital. All the patients needed evacuation, but the redirection of the community to adequate medical services was not available to them. The ability to provide all of that software as a service, 24/7 monitoring of the location, the city, as a service to the city itself, and being able to respond with off-the-shelf, in some cases, plans for evacuation, modifying them on the fly, and communicating with the general population. We think it's a real asset to the community.
Yes, sir.
Are you then sensing data at all these locations? Are you bringing in sensory data, or is it just software that tells you what to do once it's been detected? That's the first question. But I'll ask a follow-up depending on the answer.
Okay, the first question, the question was asked is, are we all using sensory data? Yes, as we phase this into, as we put this into implementation, the other work that's going on at University of Tennessee is handheld devices with remote sensors. There's also sensors within communities, and we would actually be bringing those sensors in. If you take, for example, the nuclear facilities, they already have sensors in place around their facilities so that if anything is detected, because it's software as a service, it would run 7 by 24 hours. We would be monitoring these facilities 7 by 24 along with their meteorological data. If any one of those sensors kicked off, it would then activate that scenario that is closely related to that particular situation.
Is the software that you're creating, is it proprietary, or are you going to share it for open access? And if it isn't proprietary, or if it is proprietary, are you open to something that might be better or more developed than you already have?
It is not, we do not have a chosen specific solution at this point in time. And in fact, we would invite partners, but we do have people at UTC who have been working on this problem to be able to walk around with mobile sensors on a cell phone so that as an event's taking place, as they're now detecting the toxic agent, that will report back in. But some facilities have large sensor networks, which we would tap into that, but we are not tied into any proprietary type of capabilities. Dr. McDonald, do you have another?
No, Fine.
Yes, sir.
It's a very impressive presentation here. I like what you did in terms of, looking at disaster management. We've done some of this work in the last 7 years about in the severe weather environment. And Susie was asking in terms of partnerships, and I was wondering, you had them on there, if you actually reached out to NOAA or the National Weather Service, because I think they would be an interesting and strong partner in that here. I don't know, that might be something. Also, what I thought and what I heard about, you might hear this from my accent, I'm German, Volkswagen is opening a huge facility in Chattanooga right now.
It is open, yes.
Oh, it's open.
It's
Even
open,
better.
yes.
Are you talking to them, because they might be a great user for what you're doing here, right? Because of the information you could give them in terms of, disasters. I don't know how many thousand people will work there. You just talked about that, the hospital in Tuscaloosa, right? Similar things over here. And then the final question, can you say something about the cities you had already envisioned, or is that something you...
I prefer not to mention the cities because they have not committed.
Okay.
But I will say that we have been working very closely. Our folks here have been out over the last year and a half talking with communities. They're aware of the work. We've already discussed pilots with them. So I believe that this whole initiative actually will speed that up. Regarding to your first question relative to NOAA, we're already taking NOAA data in for the work that we're doing right now. We've actually mapped out 3 different locations already, and we're doing the real-time meteorological data coming in. And then regarding other partners and so forth, again, we're open. We are stepping out here with this. We know that we're going to need a lot of help with people who can help us stand up a web service very quickly. In some cases, we have the capabilities to do a lot in-house. All these animations of real situations. By the way, this has been tested. This has been tested in the city with tracers to validate that the computational engineering did work. And the plume showed up approximately at the place it should have showed up under those conditions at a particular time. So we're going to need help, and we will be reaching out, and we do have some funding to do it. We can move this faster with additional funding.
I think very impressive project and effort you have. I was wondering, what role do you envision in this project for the fiber to the home capability?
I'm sorry, I missed the last part of your question.
What role do you envision for the fiber to the home capability?
In this case, for the fiber, a couple of areas. Number one, we're going to be in Chattanooga standing up software as a service in a cloud. We're going to be working with remote locations. And so we're going to need that high-speed fiber. One, sensory information, although sensors by themselves doesn't require a lot. But when we work with those locations and they want to do training exercises to simulate situations, whether it be chemical, whether it be nuclear or biological, we will then be able to support their training exercises, and they'll actually be dealing with very credible scenarios that are time-based dependent, which the agencies are asking for now. Right now, they sort of guess what that, I won't say guess, they try to anticipate what that is with the tools they have today. And when we start pushing GPS information that represents the points on that plume, it's a lot of data. And then the second part is that once that data gets there, and we want to start notifying people through their mobile devices, through social networks and so forth, as you may be aware, when you start pushing a lot of data, the telcos and so forth, they can process a lot of data, but you got to start pushing it out. You got to start dialing quickly. You got to burst that out. The high-speed bandwidth now allows us to push all that data so that those notifications go out faster rather than working down through a serial process.
Okay, 2 more questions, and then we can wrap up.
Okay, so it's very impressive. Obviously, there's going to be need for a lot of innovation in user interaction in this control room. Is that part of your project, or your focus is on the networking side, or how is that playing?
There's 2 areas relative to user interaction. Number one, the emergency operations centers are going to be receiving this data and hopefully receiving this a lot faster than they have been, so it allows them to make more intelligent decisions relative to dispatching. Today, the second part of it is making sure that people in mobile devices. My vision would be that 5 miles down the road, there's a chemical situation with one of the facilities here. We could all be sitting here in a room, and we're literally within seconds of each other. All of our phones are going off, and we're getting an alert message here that said that it's a chemical spill. We're in the plume pathway, although it may not say that. But what it will really do is say, here is your evacuation route, and that will now allow you to exit, get into. In some cases, they may not even evacuate. They may say stay sheltered because they're learning now that it's better to have people sheltered rather than running out into the highways and everything gets clogged up. And then there will be a pathway or routing to them. The relative to interactive, one of the things that Applied Agents does with population modeling, can you imagine they handle panic situations? A mother who's going to get a message says go over here, but her child's in school over here. And so you have to take into account through that modeling so that you can understand what's going to happen. A lot of times the mother may go to the school, but the school's already been evacuated. Wouldn't it be nice if she's getting the message that says the school is already evacuating, this is going to be the destination point where people now can start coming together. So, I don't know.
Yes. How can we or anyone evaluate that this system is actually working? And obviously we can't wait for the chemical situation to arise to see that there is need for high bandwidth. Right?
That's a very good question. And it's like in a lot of applications in this type of situation, you've got a catastrophic, you try to do everything you can to model that, prepare for it. Certainly the tools with computational engineering and agent-based modeling allows that to be more realistic in real time. There would be training exercises with these cities who are doing these on a regular basis. And in fact, just recently there has been a large NRC 5-state region in Mississippi for training. These are places where we now can go with these major exercises. And because it is time-based, we can then evaluate did people get to where they needed to be for that particular incident.
There's one response too. I think it's a very interesting question, a very valuable question. There are past events that we can examine historically, see how well the models hold up in these situations. There's evidence in those cases.
Okay, so I think we have to wrap up this session. Thank you very much.
Thank you.
Okay, next up we have Casey Wang and Dave Meyer.
Hi, everyone. So this is, as Susie pointed out, this will be a joint presentation between myself, Casey Wang, professor from the Electrical Engineering Department in Clemson University, and Professor Dave Meyer from the Computer Science Department at Portland State University. So this project we propose really spawns out of the previous USIgnite workshop at the Transportation discussion group. What we see is in the transportation domain, there are many existing problems that are increasingly more problematic and then needing new solutions to solve that. For example, the congestion issues are increasing without stopping. And then with the congestion, it comes energy issues. We're wasting a lot of energy and we're causing urban heating. And then from there, we also cause health issues because of the all the exhaust from the transportation. And then we are getting still very high casualty from traffic incidents. And so we're always looking for solutions to handle that. We are also getting new problems because we are having increasingly new solutions for the transportation system. We are starting to have hybrid electric cars entering the transportation system. And with these platforms, we are going to get more dependent on a support infrastructure to make sure that these cars will be running reliably. For example, electric cars will always need to be charging, and then they will have shorter range before they need to look for charging station. They need information to look for that, and then they will need more real-time information to inform them about important issues about their system. So with that, the conclusion is this is a complex problem, and we need complex solution. It's not just one single system that can solve it. So we need to really focus on the stakeholders, the multiple stakeholders in this domain, how to enable multiple different solutions being generated using a common or possibly open platform. And that will involve a lot of the communication requirements. So broadband networking for advanced traffic sensing and emergency vehicle support, we're really envisioning using these broadband, wired, and wireless infrastructure to come up with these two realm of application examples to show how we can design a system that we can easily incorporate new device, new solutions, and provide a common framework where these different devices can generate information from the transportation system and then make that information openly available for different analytics type of applications to detect issues and resolve incidents to improve the transportation system. And the emergency vehicle side will be focusing on what is the connected vehicle capabilities that we can achieve with this combined fiber and wireless infrastructure. So this is building on our two universities' ongoing projects at Portland State. The transportation group has long worked on building a smart corridor system to use multiple types of sensing modalities and analyze the traffic system. At Clemson, our focus is on connected vehicle, how to develop the next generation network support for moving cars. And so combining these two initiatives, we have existing pieces that we see pretty readily that can be put into a working system. So the format I'll take is I'll first go through a one-page introduction, go through the important pieces that Susie and Will suggested, and then both Dave and myself will walk through the important pieces that will enable this project. So the basic description of the project idea is we want to enable broadband media being transmitted between a smart traffic infrastructure and the internet, and then between moving vehicles and the internet. So this project basically consider three aspects. One is the ubiquitous nature of the transportation needs. So basically incidents can happen anywhere, so we want the detection ability, communication ability to be supported anywhere. And then it's complex, so we want to have multiple different type of information carried by the system. And then finally, it has to be mobile. So we have to support the portability of this communication throughout the system. So the solution outline is we definitely need the traffic infrastructure, which Portland State and with the city of Portland has an infrastructure that is pretty advanced in the field, combining multiple modes of sensing capabilities. And then we will take this broadband network, which includes the fiber network in that corridor, and then we will include the wireless capabilities to connect to the cars to make up the whole system. Their OpenFlow is the technology that we have been, at Clemson, we have been working the GigU program for quite some time. So we already have some prototype developed solution for moving vehicles connected to a wireless infrastructure. And then using that same solution, we can dynamically incorporate different types of sensors in this traffic corridor and connect that into the fiber network. So the importance, I already touched on really addressing these different transportation issues, but it also cut across multiple aspects. So it addresses the public safety issues because of the traffic casualty that is being caused. The healthcare we see is for the emergency vehicle to be able to upload and download real-time information is very important to be sustained. And then the energy issues. The novelty is really not the problem itself and probably not the solution itself, because the solution is always about getting data, analyze it, and then react to that. But what we see is the way that we have a system that can integrate these pieces dynamically, flexibly, and then we can provide some quality of service control to that based on combining different traffic type on that network. That's something that's interesting. And of course, we have novel sensing aspects that they will talk about later. Feasibility, we have existing networks, the smart corridor in Portland, and that can test our sensing concepts. And then we have a Wi-Fi network on Clemson campus that can test the wireless aspect. But then we are really hoping to take this opportunity to look for any cities with a matching infrastructure that you think that can fit into this idea. For example, we need fiber to the traffic infrastructure, light poles, things like that. And we need wireless coverage across the city. So we'd love to talk to some potential partners there. About scaling up, we think that with these, the infrastructure definitely takes time and capital to build up. So one possibility is that existing city partners, if there are suitable infrastructure, then we can look at how to integrate that. For the emergency vehicle or the open flow solution itself is pretty portable. And then it can be easily enabled with low-cost hardware and software solutions. So we see that feasible for scaling up.
So just to set a little bit of context on the Portland side, to do something in the short term in transportation, it requires there to already be a lot in place. And so looking in Portland, there's a project underway in Portland to install SCATs. It's called Sydney Coordinated Adaptive Traffic System on a stretch of Powell Boulevard. It's one of the main east-west corridors. The goals for such systems are to do better traffic control for reduced travel times, reduced emissions, improved safety. There's various sensors out there. You deploy various sensors. This stuff is hauled back over a fiber internet and analyzed and used to control the signals. It's scheduled to be deployed this summer. There's already something called transit signal priority in place for buses along the corridor. The cabinet is not SCATs. The cabinet is there just to show that there's close cooperation between Portland State Intelligent Transportation Systems Lab and City of Portland. That's one of our computers sitting in one of their signal cabinets and hooking up to their intranet. In terms of So Portland State is involved in evaluating the effectiveness of SCATs and other improvements along the corridor. The reduced travel times you can get a good handle on with probe vehicles. Improved safety, you can count incident reports. The emissions part, well, it's a claim, it's never really been very well validated because people use models of cars and emissions, and yet when you go out and measure two vehicles in the same class, like two city buses, you can get an order of magnitude difference in their emissions because of age or something that's not figured by the models. So what Portland State is doing in an existing project is going out and measuring the air quality, among other things, the air quality before and after SCATs. That involves additional deployment of sensors, so meteorological sensors, ultrafine particulate and dust sensors, carbon monoxide, nitrogen oxides. Plus we get this data comes back to Portland State. There's the radar-based traffic counts and characterizations, the transit signal priority. There's a bus dispatch system that can tell you where the vehicles are, how many passengers get on and off and such. That comes back. The main sponsor of this project is the city, and then there's funds from a local transportation DOT center, but the public transit, the DEQ, Oregon Department of Transportation, are involved. What's missing here is that they'll be able to get levels. You're still not getting a handle on exposure. That is, who's there breathing this stuff? And so the hope, our thought was if we had some video that was good enough to detect all mode transportation, so not just the cars and the trucks, but the bicyclists, the pedestrians, the joggers, and determine their numbers and location, then you could start getting a handle on, what are people actually being exposed to, what are not just what the levels are, and think about means of traffic control that take this into account to improve things like public health, emissions exposure or emissions production, and pedestrian safety.
So this is just a quick overview on the open flow expertise or experience that we accumulated so far at Clemson. So as part of the Genie project that we have been working on multiple different dimensions, trying to put together the Genie components. So we have been deploying OpenFlow on our campus Ethernet, and then we also deployed that on the mesh network that we actually hand them on the light poles and tested with moving vehicles. So this is something that's very relevant to this project. And other than that, we also look at the WiMAX. We have a team that is looking at using Genie's Open WiMAX solution. We see this as something going forward. We don't just want to look at a Wi-Fi type of wireless network, but we want to look at a citywide, wide area wireless network. So if there are suitable WiMAX opportunities, that we also will have experience of using that. And going down, there are software-defined radio research, peer-to-peer research. These are all just different ways of programming the Genie network, and that is something that will be useful when we try to port these software onto the Portland system. And we have do an initial analysis. We think that it should be pretty easily portable. Clemson, the campus itself is one of the earliest campus that have the full Genie software paradigm running right now. And then, so with that, what we see is we have experience on putting OpenFlow and the Genie software running on a wired and a wireless network environment. So the interesting part is, again, given this workshop and Susie suggested this quick turnaround opportunity to show some motivation of going to the future with a broadband world, I think it will only get the higher impact that we expect when we actually show the business model working with real economic partners. So these are the companies, industries that will be interested in these technologies. So Clemson has a research center called CUI-CAR, International Center for Automotive Research. It basically is a university and industrial consortium. So there are many companies, especially focused on sustained mobility, that are hosted on our campus. And then we already have companies with BMW being one main anchor. Beyond that, we also have electric buses, electric energy storage, energy transfer companies that are hosted there. And with one of the major projects coming out of this is the Project Green. So we are independently using public-private partnership to build an independent test bed that is going to be open for the ecosystem that builds future electric hybrid traffic solutions. So there, the interesting part is there are a lot of telco partners that have already been working with Project Green. So that gives us the opportunity going further. We will have an independent test track that's on an airport that we can use for testing these real solutions. So some of the automotive manufacturers is already on board. So the project benefit, I think we already walked through most of them. So basically what we see is to enable sensing, video being one that is very high bandwidth, but all kinds of sensing from a more diverse range of platforms. That is not what we typically have today. What we see is in today's traffic system, trying to deploy fixed infrastructure for sensing to solve this complex traffic problem is not sustainable. So we need something that is more easily available on individual users. So on the cars, on the pedestrians, automobile devices, and car cameras, we can integrate a lot more information from them as long as there is a reliable network that we can link to. And then, so better traffic control, better emergency management. So these are all the different pieces that we talked about already. So I think I'll just stop here and open for some questions.
The partners you guys have talked to appreciate this perspective. What have they told you about the business model? What they see as opportunity for value creation?
So you want to first talk about Portland side?
Go ahead.
Okay. So from Clemson, CUI Car has been working with a connected vehicle consortium. There are many partners that what they look for is what is a paradigm that we can build such that these different businesses will be motivated to come in, easily build a solution and integrate into that. Because right now, we talk with federal and state level DOTs. They said the main problem is not we don't have the technology to do intelligent transportation system, but we don't have the fund to deploy that. So they're looking for private investment to do that, but the private investment haven't seen the reason to do that. So we recently participated in the DOT competition to come up with this idea of how to allow multiple sectors to come in, and what we think is one single platform that can accommodate different wireless technologies and different applications. For example, Starbucks can easily come up and write an application and say that if you're willing to use our service at the same time, we can contribute a certain amount back to this intelligent infrastructure.
I think from the Portland side, it's probably the economic possibilities are mostly with municipalities that are trying to do something for sustainability. So, you know, this piece fits in that, you know, if you can improve things like traffic management, then you have, you know, sustainability on the energy side because your potential for fuel savings, sustainability in the fact that you're trying to, you know, as population grows, you're trying to keep the pollution from growing and making things more livable. You know, also as traffic grows, being able being also, I think indirectly being also able to encourage alternate modes of transportation. And what will, you know, if those become safer or perceived as safer, then that might encourage more people to be biking or taking public transit or walking.
So I'm curious about the video resolution. How does increasing the video resolution or using more bandwidth for the video contribute to getting a better solution, or does it?
Yeah, this is one of the questions in active discussion right now in our group. You know, I've met KC face to face for the first time about 2.5 hours ago, but this is, you know, so it's been by phone and stuff, and we're trying to get a handle on what level of and what density of sensing we would need to be able, for example, to count pedestrians waiting at a bus shelter or joggers or number of bikes. And, you know, you could probably, you know, individually, you know, if it probably doesn't have to be as high as HD to do that. You know, you probably, if you got down to certainly the sort of the levels of Bluetooth, I mean of Blu-ray, which is actually only about maximum of 40 megabits a second, you probably could get a lot of you know, have enough image there to do the kind of analysis you want to. Now, you'll need multiple of those to get things like ranging and distance. So it may not be pushing the video alone may not be pushing the very high end. I think one of the interesting things with the OpenFlow part is being able to adjust which things get priority, getting a slice of the network that, you know, the emergency vehicles get priority for their getting looks and stuff when they're in the picture. Otherwise, you've got to keep the signals running and do the basic sensing, but you would like to do as much of the video as you can without compromising that.
And I can add a quick comment to this question too. We had a project running on Clemson campus for 2 years. We have another faculty doing video processing. So he actually had a software. You can install it on the highway, and immediately it tells you how many cars are going by and track each individual car. And then it knows what type of car you have. You have truck, you have cars, you have motorbikes. And right now, I believe that group is working on pedestrian. So using that, the question we see is not the individual video streams resolution, but eventually how many streams you want to put together. Because for one stream, for that software to work, it doesn't even need a very high resolution. A regular webcam quality, it works perfectly in terms of counting. So then you can expect that the question is how many users can simultaneously submit their signal coming into the system and be able to do something useful. I think there are existing products doing that right now, and we are not using HD. We actually have a product deployed on campus that is just regular. I don't know the exact resolution, but it's not very high.
Yeah, most of this traffic data that comes back to Portland State gets archived. We don't archive video currently. You know, we tend to analyze it. You know, for doing things like travel times by capturing the same vehicle more than once, we've actually found that better than the license plate reading is to put MAC address readers out there and just see which cell phones, and you know, just watch your smartphone go by or watch a whole bunch of them go by and figure out it's a bus. In that picture, how do I go back here? Yeah, so what this is actually going outside is there's a MAC address reader up on a pole outside, and this is reading them off of cars and then matching them up with other places up and down the road to see how long it's taken people to get from place A to place B. I mean, it could, you know, people could subvert it by, you know, throwing their cell phone out the window or something like that, but it seems better than the license plate reading.
Or carpool.
Yeah, can you arrange an automatic email that says I'm going to be late to the meeting?
Well, we quickly anonymize the MAC addresses.
Okay, they got one more question.
I see how you have the, tied into feedback loop where you make certain adjustments to the existing system as it's operating. What about the modeling, interfacing with modeling capability, for example, planning for large events or, as we saw in the previous presentation, disasters, that type of thing where all this real-time data coming in, could be run in terms of various imagined scenarios. Is this a component that you see coming in at some point with the project?
That's interesting. We hadn't, our brainstorming has been limited. The one place that something like that comes in is that there's a high school nearby, and they want to do some modeling about how, traffic control and other sorts of things, affect both people. Trying to reduce the people driving there, but also modeling what happens at the busy times of day. What effect does that have on? They're mostly interested in what effect that has on the sort of pollution profile when you have all the students leaving or something at once, or people dropping off in the morning. But the broader thing about some kind of event is an interesting one.
Okay, thank you very much. Okay, next up is Mark.
This? Okay.
And Morley. And Michael.
Yes. Okay. I'm here to try to gather up the prolific ideas of my colleagues, Morley Mao and Misha Rabinovich from Case here. Morley's from Michigan. I'm from Ohio. It kind of pains me that I had to put that logo up there. Story for beer later. Okay. So obviously, we're talking about broadband networks, and we can run sort of our traditional applications on broadband networks, and they all run better, and that's great. And what we've been trying to do is we've been trying to think about sort of what these networks sort of enable, what they can do in terms of organizing the overall network and the information in the network to help make a bunch of applications better. And so as sort of, I got it good. I'm not a PowerPoint guy. We've been sort of framing our thinking in terms of this little taxonomy of applications here. And we sort of throw all these applications we can come up with that would be useful for broadband into one of these sort of three categories. The first one is pretty obvious, right? So applications that need tons and tons of bandwidth. The second group are applications where we think we can lower the user perceived latency and hide delay from users. Okay, so we can't change the actual latency from here to San Francisco, but we can use the big bandwidth to try to hide that. And our sort of third category is somewhat of a catch-all here, which I've titled flexibility. And this is a bit more nebulous, and it's sort of what can we add to the network to do things like help people's privacy or help them to organize their devices. And I've got a couple examples here of this. And so we have thought about three different applications, and as you'll probably detect, they're sort of tangled together a little bit if you think about them for just a minute. So let me go through those real quick here. So the first application, something we've called a smart proxy. We're not very good at naming things. That's kind of boring. But this goes to our sort of latency issues. And can we reduce latency that the user experiences by using a bunch of the bandwidth? And if you think back, like web caches, they try to play this game where they can reduce the latency of loading things by caching objects. So if I load something, it sort of saves it, and then Will comes along and tries to load the same thing. He gets it from the cache. It's much faster. So that's been done. Also, prefetching has been done too, where the cache not only passively watches, but tries to predict, you're going to get X and Y and Z. And so I'm just going to grab those, and I'll have them ready for you. So we want to do both of those things, but we also want to add two new wrinkles here. And one of them is that we want to coordinate this prefetching sort of within a geographical area. So if you can think about the neighborhood you live in, bunch of houses all connected with gigabit fiber, and we might all sort of suck down a couple Netflix videos or something, and then all of a sudden we have the top 500 Netflix videos sitting there in very close proximity. This is sort of a trivial example about movies, but it sort of gets you where we're going here. Another area where these proxy caches are problematic is in the terms of dynamic content, which is so much of the web now, right? So your Gmail is different from my Gmail. Your Facebook newsfeed is different than my Facebook newsfeed. And so what we also want to do with our smart proxy is we want to move towards a model where that thing is actually an agent that's acting on your behalf. And so we can load it with your preferences. Here's the sites you like to go to every day. We can either configure that in, or we can sort of make the proxy learn that. But we can also do things like give it your Facebook credentials. So it can watch your news feed and then maybe go chase all the links on your news feed, the videos, the pictures, anything. And this is all sort of enabled because we have this big bandwidth just sitting there, you know, most of the time unused. And so we can just start copying the internet to either you or close in your geographic area. So the second application is called Data Attic. Again, very snappy, I know. And so this is sort of goes to where you keep your stuff, okay? And you know, sort of we now keep our stuff on maybe our laptop that we carry around in our backpack, or we keep it in the cloud or somewhere. But what the fiber to the home enables us to do is sort of what Misha refers to as provide a bit of a reverse iDisk. In other words, you store your stuff at home, and now it is trivial to share that with the world. You don't need a Google or an Amazon that's a big provider that has lots of bandwidth. You have the lots of bandwidth yourself. And so there's a bunch of different applications here, but I was told I had 10 minutes, so I'm going to do one, which is the third bullet down here, which is think about sort of aggregating your medical records in your house. So that's sort of everything from every medical provider you go to, right? So that's your dentist and all your x-rays from some lab and your visit to the hospital and whatnot. And anytime you go to the doctor, any doctor, you can sort of give them access to this. So for instance, I'm traveling in, you know, wherever, Boston, and I get in a car wreck and I end up in some hospital that I have no previous relationship with, I can still get at sort of all my stuff, all my medical stuff, and can provide that to the hospital. All right, that brings us to the third thing here, which is sort of how does broadband fit in the sort of overall network ecosystem? And I've got two examples here. One that I've sort of been noodling on and find striking is the sort of dichotomy between big broadband at home and the cruddy 3G network that I carry around in my pocket. On the one hand, one of them is sort of too massive for me to even think about loading much of the time. And the other one, I'm always cursing because it's too anemic and it's always slow. And so the question is sort of how can we leverage our multiple devices and our multiple points of connection in the network sort of in a synergistic fashion. And so we've been thinking about using your house, something in your house, as sort of a starting point for your phone, okay? And we can do, as we discussed on the previous slide, we can do prefetching, we can do things like that. But what your house can do, it has a lot of computation there, it has plenty of power, it has plenty of network, it can do adaption of the content for whatever device you're going to render that content on at any moment, including your smartphone. So it might have a sort of cruddy version of the video that it sends over the 3G. It can also do filtering. So you might decide you can configure your I don't know, I mean a trivial example is your Twitter feed. You might want only a little bit of your Twitter feed on your phone to sort of use that bandwidth wisely and not sort of a bunch of chit chat that you like when you have a big screen like this in front of you or something. And so it seems that that's all possible. We can give people a way to enable the wise use of 3G where wise is determined by individual users. And the other one here where we sort of think about broadband fitting in the broader network is that broadband really sort of flips us back to where we started with networks. When we started the internet, all the links were 56K. It was easy for the endpoints to overrun the middle. And we've spent the last 15 or 20 years changing that equation so that now the core is very, very over-provisioned. And it's either somewhere between hard and impossible for the ends to overrun the middle these days. And so if we let Lev give everybody a gigabit, how does that change the the internal network. And are we going to really need to do things like these scheduled downloads of Netflix or whatnot to sort of smooth the demands and you know, bring that stuff into sort of a more into your sort of close geographical area? And are we going to need to employ a bunch of traffic management and stuff to sort of start protecting people from each other? We have some sort of terse plans here. We'd like to sort of prototype all 3 applications. They're not exactly 3 applications, as you see. I sort of weaved prefetching throughout this. We'd like to go ahead and prototype it here in Cleveland and CCZ, and perhaps scale it up. You know, how do we measure success? This is a bullet that I think at least I struggled with. I said we were going to reduce latency, and that's very easy to measure. I'm a measurement guy, and I can measure latency. Measure X, measure Y, compare. And we can do that. We can do that. But the things like providing you with a place for your health records, to store all of your health records, I'm not exactly sure how to objectively say that has improved your life by, you know, X%. And so some of this is a bit more nebulous, and so I think we're going to have to sort of invite the users and the domain experts to give us feedback in these sort of areas to understand what we're doing. There's a final note down here. Already over here in the case connection zone, we do have a little bit of measurement infrastructure in place. So we're sort of starting down that road. And this is my last slide. Basically, the summary here is that sort of the way we organize networks, the way we organize information in networks is sort of this constantly evolving process. You can think about it as sort of starting with a client and a server, and then it sort of, we added caching proxy servers into the mix, and then we added web farms and moved to CDNs and clouds and whatnot. And so what we see here is that the bandwidth that broadband provides it's just sort of one more shift here that lets us perhaps evolve that information organization again to the user's benefit. So I think that's it, and I hope my colleagues here will correct anything I've messed up. So, question?
Mark, thank you. You've got 2 words on that screen that I zeroed in on, trust and security. Being paramount. You talked about privacy and its sort of looming role in place here. How do you anticipate sort of the participation amongst the actors in the community? Sort of how do people enter into the system and participate, sort of create the trust relationship so that you actually get the network effect that you kind of want out of this? And you certainly anticipate putting a lot of that at the node within the system, probably a couple of different ways to think about it. How are you guys thinking about it?
Well, so I can't walk. I hate that. I'm like a walker here, so you know. Let's see. I'm not exactly sure I fully understand this, but so one of the things we talked about privacy, but one of the things about trust is if you're able to store your information at home, then and make your medical records available to the Cleveland Clinic or wherever, you know, you sort of get some more trust. You're not trusting a third party. I mean, that's part of our goal here. We don't have to trust them to secure your privacy. Is that getting at part of your question?
No,
or
let me walk through a scenario. Maybe
that would help. Yeah.
I have my child at school. My child has special needs. He may have actually potentially been incarcerated, right? As a caregiver and an adult, there may be a set of interventions that are important for that child, but there's a community of actors that provide services for that child. It could be the YMCA, it could be the Cleveland Clinic, it could be the judicial system, but all those folks who have to have some way to actually interact with the system. How you bring online those actors and how you actually allow them to participate requires some level of trust. It could be established organization. The Department of Justice probably has a brand associated with it. If it's a local foundation that may not necessarily have brand recognition, how do they actually participate in the system? So how do you establish the trust networks? How do you bring people online and actually allow the network effects for this to actually take off and do its scale? Yeah,
So I don't know that I have a particular model in my head of this, but I mean, one can envision, I'm visiting town, I go over to the clinic, I need my medical records, I can somehow log into my home machine and get those. And so you can also think, well, maybe you can go to the Y and you're signing your son or daughter up for whatever class and intervention they need, whatever, and at that point you can sort of authorize them for particular information or to work with other providers, the school system or what have you. Does that help?
Let's talk about it. Well, maybe I can try if I understood you correctly. So if you have a provider for the sick child, you clearly have to trust that provider, that the provider is well-meaning. Now, what our system allows you to do is to provide, to give access to this provider to the necessary data without you relinquishing control over that data. So you don't have to trust the provider to safeguard your data well. And if you decide to terminate the relationship with the provider, your data is still under your control. You didn't give it up to the provider. So in that sense, we think that our idea enhances privacy. But if you allow the provider to do some intervention with your child, at this point of time, you clearly trust the provider.
Yeah, I think that in these kinds of examples that you gave in that health record example, we're working on the assumption that you've built some out-of-band trust with your peer in this. Does that help? Okay. And what else? I've stunned you all. There's all a break.
So, if I understand this, like your whole project is dealing with caching, and you have the idea of inbound traffic that you consume locally at the home, but you also have outbound traffic, like the example you gave is medical records. So how do you deal with failure in that case? Like, if I'm in the emergency room when my server is down, I can't call my friend to turn my computer on.
Yeah. So so there's a bullet here, and they told me I had 10 minutes, and I'm just going to throw my colleagues under the bus. They kept adding bullets. No. We have some ideas. So perfectly reasonable question here. And our notion is, well, perhaps we can actually form our own sort of little cloud, right? Where, yeah, you know what, you'd go to your home, all right, and you'd get your hospital records, but there's power glitches and maybe your home isn't available. So maybe your information is actually also encrypted and split up among a few of your friends in sort of geographically different areas or something like that, so that there is a backup there. And this is, again, possible because we have this big bandwidth. So why not just sort of strip it out and farm it around?
Like a Tor network.
I wouldn't call it a Tor network. I would call it more like BitTorrent.
Well, okay. And I would assume that one of the challenges is even convincing people that they need to have their medical records stored on their PC.
It's a fair point, right?
Okay, thank you very much. So Lev came by, we're in a race against time. He's telling us that there's wind out there and it's starting to get dark, and we really want to finish by 4:30. He claimed he will still not get wet if we leave. So, Suma, I'm going to ask you to go tomorrow. Because I know you so well that you're going to give me a hard time about that.
I was scheduled for tomorrow anyways, and I was getting moved on.
Yeah, I right, exactly. But we really have to have two more presentations, right? So we've got George next, and then we've got Jeff. We've got to finish by 4:30, so we can walk to the reception.
So I'll talk with you a bit about an existing project at Purdue University, the Visual Analytics for Command, Control, and Interoperability Environments project. It's funded by the Department of Homeland Security. It's been running for about 2 years. It's had $15 million in base funding, but they've already been funded about $9 million in the first 2 years. It's led by Professor David Ebert and is a large collaboration, as you'll see. So let's see, forward, there we go. So the mission is to research, develop, and deploy interactive, visual, analytic environments that will communicate and disseminate information and derive insight from a deluge of data sources. So the idea is to take all of this information in, analyze it, develop insight, and then provide back out to all of the emergency responders, to members of the community, to whoever might need it, actionable, digested information, and to engage a broad community in this activity. So it involves a large number of partners, as you can see from the map here, and working on a number of different projects, which I'll outline. There are 75 faculty at 19 different institutions already a part of vaccine. It's a very interdisciplinary activity. It's located at Purdue's Discovery Park, which is the interdisciplinary section of campus reserved for strictly interdisciplinary projects such as vaccine. It works in 4 major areas: in training and education. It's been working with the Federal Law Enforcement Training Center, the Justice Institution of British Columbia, K through 12 institutions, university, higher education students. In public safety, locally around Purdue with the Tippecanoe County, various public safety agencies, police department, emergency response, Indianapolis, but also across the country, Atlanta, Harrisburg, Pennsylvania, Charlotte, North Carolina, so forth. A wide variety of federal agencies, Department of Homeland Security activities span many agencies besides DHS, so the Coast Guard here has been involved, Customs and Border Patrol, Center for Emergency Response Teams with respect to cyber infrastructure, NGA, National Geospatial Intelligence Agency, a lot of acronyms that may be less familiar here, and corporations as well, as you can see. So what are some of the projects that have already been done to give you a sense of some background and framework for within which USIgnite might be working? So the team has developed an interactive analytics dashboard for defense, nuclear defense office, detection office rather, to conduct a full-scale exercise in Seattle with the Coast Guard. So that has been deployed and really tested out there. Law enforcement tools and evacuation planning tools, working with the Charlotte City and Mecklenburg County area in North Carolina with those police departments. Developing sort of a local thing, a hazmat signing and a gang graffiti mobile phone application so that citizens can take pictures, geotagged, and you can see what's happening out in the community in response to, in regard to these areas, and then think about responses and get a real community involvement. There we go. It's also deployed a cybersecurity visualization and analysis tool for US CERT, and visual analytic tools to help Customs and Border Patrol with the massive amount of data that they work for to look for correlations and whatnot. And they're beginning a project that looks at applying, again, new generations, new ideas, and visual analytics for disaster prevention and response to a crisis. So now with respect to USIgnite and the Gigabit, our thinking is to take these fundamental tools that are developed and being further developed and apply them to increasing safety, security, and emergency response with community-sourced information. So use this gigabit bandwidth to move a lot of data around, particularly video, to allow these automated analytical tools that have been developed. And I might say that for those of you who are familiar with the hub technology coming from Purdue and, for example, NanoHub, the visualization of simulation results is code that was written by David Ebert and his group here from Vaccine. And we have very nice visualization capability. This group delivers some very valuable software in that area. And then use this advanced real-time analytics and data fusion to deliver this actionable information for increased situational awareness
and the effective responses. Providing that information back to the citizenry, emergency responders certainly, but perhaps a much broader view of the citizenry that are involved to increase their safety and their effectiveness in responding to whatever the situation might be. So in a more of a picture form, you can see here, broad set of elements here in the community, emergency responders certainly, but the general citizens, special groups, whatever makes sense for a particular problem area of interest, and that's why I'm very interested in talking with those of you here who might find this interesting to find that pilot demonstration project topic that really works with you. Taking in data in all kinds of forms, tweets, photos, video streams, from the cell phone, from the cameras that are around, text messages, other kinds of messages, sensors that are out there, whatever kind of data sources you might have, bring that into a database that's then analyzed, and particularly these visual analytics in addition to the kinds of trending analytics we see with Twitter streams and that kind of thing. Put this all together into an integrated analysis, geocoded, real time, the kind of thing that's being done that then helps first responders know what's happening, how to most be effective, and then provide that coalesced actionable information out into whatever community is involved. So it could be the first responders alone, could be much broader, could be these messages to the mom saying your evacuation route is in best this direction, where you can rendezvous with your child who's already en route with this real-time type information. All of those kind of things are a possibility here, and these analysis tools and the Gigabit are what help bring this all together into that effective, coalesced, actionable stream of information that can be pinpointed where it's needed. So that's the idea. It's a group that's been working now broadly in a very interdisciplinary and distributed fashion, and so I think there's a lot of potential to bring this together, and I'm very interested in hearing what you think about it. So questions, comments? Nobody wants to get wet, that's why I kept it short, but still, there we go. Yes?
This may be a little far afield from what we're talking about here, but this visual analytics could be used for mapping, let's say for identity detection.
Mapping for identity detection?
IED.
Oh, IED detection. I would certainly think that with appropriate sensor networks that are monitoring an environment to detect the IED events and then bringing that back, certainly. That seems like a quite reasonable thing to be able to do with this type work, as I've seen them do it already. So I would say yes. Next.
So I'd like to ask what some of the Chattanooga people are thinking about. You have some very similar projects, right? And I'm interested in kind of what the differences are, or how you see some of what you're just doing, how it might fit in, or.
Excuse me.
I think it definitely would fit in.
I do too. Yes.
There are elements of the latest programs that we have today that extremely useful in the overall system. Recognizing work, for example, this type of add-on really could make a huge difference in the information that we receive in order to process and determine the Thursday, I think it would be very, very helpful. So there are elements of what we're doing today that clearly can be incorporated into what we would like to do, where we see ourselves growing and would like to find out more about it.
All right. Yes.
Just elaborate a little bit on the coalesced actionable information from the perspective of the community user. How does that come to them? Given the large amount of information, the visual integration, and so forth,
right?
And then feeding that back to the community.
Mm-hmm.
How does it make transparent and accessible?
Right. So the challenge here is we've seen in a number of these presentations there are aspects that come together. So, for example, on an everyday basis, the actionable information in the traffic study at Portland was to, for example, I found very interesting personally, look for concentrations of people in adjacency physically with acceleration events or idling events so that they're more exposed to the emissions from transportation vehicles. So you need an analysis of the video data that can recognize people as opposed to a different kind of analysis of video data that might be looking for some other characteristic or aspect in the video. And you need information about where the vehicles are idling or accelerating. So you see that there's opportunities to tailor the analysis based on the end use. And so that's what I would envision here is finding some key pilot projects where we would use the algorithms that may already exist or perhaps develop one or two, showing this valuable application, showing the benefits rather quickly, and that puts you on a path to think about, okay, how do we move forward from here? And so there's a nice ability to combine maybe projects with sort of an everyday application, immediate application, with these applications that have the broader, bigger picture and are dealing with the much more severe but rare situations as we work our way to really understanding how to deal with those by building up from things that we work with every day and can measure and have good metrics on their impact. So I like that kind of staged approach that I can see coming together here. Last question, perhaps? Yes?
I was curious, it looks like you've really developed a wonderful superstructure on top as we handle the works of pressure all the data. Have you been working with people to some bottom up as well? Like some of the public safety first responders or citizens feedback on how
Right.
fits their requirements?
So have we worked from the bottom up? So I would argue that yes, we have with the hub technology at Purdue, which is designed essentially to let you run computer applications by pressing a button in your browser, not doing things locally. Use the network to move the results, but let the computation happen where it needs to. And with the hub technology, we put very simplified user interface wrappers around what might be fairly sophisticated codes so that an end user can, more like an app from the App Store, access sophisticated computation by the click of a button and not having to write an Excel macro to make a spreadsheet do something very interesting and very valuable, but nonetheless requiring you to spend a lot of time learning Excel macro language. That then begins to give us this bottom up where a broad section of the community can provide both input or maybe access then data that is centrally collected, as you see here, and do their own local analysis for their own particular needs. And so that's why I argue that this can help make the citizen not only know, for example, a good response, but also maybe be part of an effective response where they're not only, say, evacuating, but they're maybe reporting and maybe analyzing and then helping others around them in a way that they wouldn't without this quick ability to mine the data and get effective information back. Thank you very much.
I'll be quick, I promise. None of those look like. If you're online, I can get onto my Gmail real quick.
Yeah, we might have to do that. Because I think the only one.
Yeah, I sent it at like 12:30 today.
Well, shoot. All right, technical glitch. Let's try getting online.
Okay, I'll go ahead and just pulling it up. Actually, I need to log in here, right?
Yeah.
All right.
Close that crap.
Okay. No, I don't think I want Lev getting in my email again after this.
Just open it. Nice.
Cool. All right. All right, excellent. Howdy. Jeff Daly here. I'm here from Lafayette, Louisiana. I've got a nonprofit I've started up called FiberCore. We're all about facilitating projects that leverage advanced fiber networks, in particular by engaging the community, so that if you want to do a project in Lafayette, I can bring to bear all the resources of the community in order to be able to accomplish that pilot. I should go ahead and start off by saying that I've got the ugliest presentation. I'm also probably the lowest IQ of all the speakers you've heard so far today, so I'll apologize ahead of time for that. Also, as you see, we are on the theme of public safety yet again. The reason for that actually is that this idea grew out of the last USIgnite meeting. I was part of a roundtable discussion on public safety. Through our conversation, we came up with an idea. Some of you may have heard this from before because I started the initial presentation of it at the last meeting. I went back to Lafayette, started sharing the idea around with some of my colleagues. One of our main partners down there is the Center for Business and Information Technology at the University of Louisiana Lafayette. It's a UL research center focused on researching, developing, and commercializing advanced internet technologies. Turns out they had the exact same idea that they had been talking about 3 days earlier. So it seemed like there was some synergy there. So I will say that this is, I won't even go so far as to call this a project yet. It's an idea at this point. It's something that, again, it just kind of came to fruition the last couple of weeks. And now we're working on saying, hey, is there something here? You know, is there something here worth pursuing a little bit further? And what's interesting is how it actually complements the other presentations that we've heard so far today. So the basic premise, and you guys have heard some of this stuff, but it's a slightly different way to look at it. So there's a need of having real-time, multifaceted situational awareness to help guide the speedy and effective response from public safety agencies. You know, that's of course been the premise of a couple of other presentations already today as well. We see an opportunity though as well, the fact that we've got tons of sensors out there, but not just sensors in the traditional sense, but also, as has been referenced, mobile phones and the like. All this potential data streams out there. There's lots of ways to analyze this data. There's lots of ways to visualize this data. And there's now increasingly be more and more interesting ways to display this data. So how do we combine all those four together into one whole package? To develop new apps for real-time situational awareness that combine these four aspects in this way. And then in particular, that leverage large-scale displays, high-speed optical networks, and high-performance computing systems to set a new standard for real-time situational awareness. And so the way we're thinking about this, we've broken it down into these different areas because there's an overall vision for what the product looks like, but it's broken down in these areas because each of them have their own unique challenges associated with that. We also believe that each of them already have existing technology in the marketplace, a lot of which hasn't been tied together yet. And there's an opportunity to be able to tie that different research together while also doing some original research to help fill in the cracks between those. So ingest is pretty simple. It's the idea of we've got, how do we be able to take in as many feeds as possible from as many sensors and cameras as possible. And so, for example, you know, there's an increasing number of security cameras, mobile cameras, cell phone cameras. There's potential for temporary cameras to be set up around emergency events. How do we find a way to get all these feeds coming in? You know, that's challenge one. Challenge two is how do we find ways to analyze these feeds, in particular to prioritize the data, as some of what we were talking about earlier, so that we can in real time. One simple example, I should mention that we're particularly interested in video, just because video is the thing that's really going to be pushing the bandwidth envelope, and it's also going to, when we're talking real-time situational awareness, video opens up a lot of interesting possibilities. So from an analytical point of view, how do we analyze that video stream in real time? So say we have 10 camera feeds coming in from the same incident. That's happening in real time. Can there be a system that would be able to automatically, without human intervention, determine which are the highest priority feeds, camera feeds? You know, so if there's a burning car on a highway and there's 5 feeds coming, you know, all showing it, which is the one that's going to give you the best angle? Is there a way that you can go and then look at all the feeds, but then get the highest quality picture of the ones that matter most in that way? And then there's all sorts of other analytics that can be done as well, the facial recognition, the license plate recognition. We're actually, CBIT is doing some work, or as Casey was talking about, on doing being able to count cars using traffic video for evacuation planning. Obviously a big issue down in South Louisiana. Now visualize, now that's where I think things can get really interesting because there's a lot of visual, and that's why I love it. It's so complementary to what was just up here in that way, because there's lots of ways to visualize sensor data. Well, we even want to take that even to another level and say, how do we visualize, take all these incoming video feeds and use them to create new visualizations we didn't have before? So for example, there's work being done in Lafayette, UL right now to be able to automatically generate 3D models out of video feeds, even just one particular angle on that video feed. So now what if you have multiple angles on that video feed, and in real time you create a 3D model on the fly? So you don't have it sitting on the shelf that you can go use, because there's going to be situations where that happens. But you can automatically generate one on the fly using satellite data, using camera data, using potentially LiDAR data, other forms of data in that way. Also, though, is there possibilities whereby we can actually use multiple two-dimensional video feeds to create 3D video? You know, there's work already being done to take multiple photos and stitch them together, right, from different angles to be able to create a 3D image. Well, what is video? It's just a series of photos, right? So I mean, I'm oversimplifying, of course, but we think that there could be some interesting potential to be able to, again, on the fly, you're creating a 3D video of the event that's actually happening. So what can that mean for real-time situational awareness when you could do your own flyby camera through something, even if a camera doesn't exist, for you to be able to do so? Get an angle on something that you don't maybe have a direct view of. And then the final thing is, and this is also where it's getting, because another thing in our thinking on this is that we want, for the kinds of projects within USIgnite, well, this isn't an inappropriate word to use, but I personally, I want to see something sexy come out of these projects, right? Something that can capture people's imagination and go, whoa, like, the average Joe on the street, who doesn't know anything about telecom. Make his eyes pop out of his head, or her. So the display, I think, is one area where we can go, and all the stuff we've already talked about is exciting, but in particular, I had a chance, at the last meeting, I had a chance to meet Michael Donovan from HP Labs and go out and tour their facility in Silicon Valley a couple weeks ago. They've got technology called Pluribus that allows you to take standard off-the-shelf projectors and create large 30-foot and bigger screens that can do 3D video in a big kind of way. So now imagine, we're kind of tying it all together here. You've got a system that can ingest an infinite number of feeds, or, it probably always has to be a finite number, but, extremely large number of feeds, in particular video, that can analyze that video in real time to prioritize which are the highest priority feeds, that can take those feeds and then create new visualizations as a result of this incoming video from different angles, and then display it on a 30-foot screen so that when there's an emergency happening, that you're actually literally seeing it all right in front of you in that kind of way. And that's, again, the general idea of what we're laying out here as a potential project. I mean, there's endless applications for this. Some of the ones I just wanted to mention here, these first three all relate to the projects actively going on at UL right now. A levee monitoring system they're working on deploying. I talked to some folks around that. If they could have had the ability to turn on every camera that was looking at the levees at one time, see it in real time as the floods were coming in, could have totally redefined, because it was, trust me, there was a lot of like, so what's going on? Anyone know what's going on? There was a lot of that kind of stuff going on. That could totally change that. Of course, post-disaster damage assessment, evacuation traffic estimation, again, another thing they're working on, as I just mentioned. Large event management. Anytime you're going to have lots of people around, especially in an urban environment, there's going to be lots of cameras there of some sort, even if you don't go install new ones, just because of the prevalence of those. And so being able to react to incidents as they happen in that way. I went ahead and listed through some of our potential partners here. Again, I want to say potential because we are just starting to engage in discussions with them. I wouldn't claim any of them actual because, again, it's more idea than project at this point. So the NIMSAT Institute is actually an outgrowth of CBIT, as I mentioned earlier. It's the National Incident Management Systems and Advanced Technologies. And what they do is incident management, event response. They're actually in charge of the disaster response for the state. So if something is, if a hurricane's blown in town, the gentleman who runs it is driving up to Baton Rouge to meet with the governor and his cabinet. They've started a business extension up. A business enterprise operations center, I believe is what the acronym stands for, essentially a way to activate private sector resources during an emergency. They do a lot of interesting work around this space. So whatever we would be doing at a local level in Lafayette would have a direct line to the state level in that way. And that's one we do know as a partner. Another thing's happening at UL is they're starting up a center for visual and decision informatics. Essentially, you have massive amounts of data. Now, how do you actually get insight out of that data? It's just getting started up right now, hopefully as a National Science Foundation research center. Henry Chu and Arun Lokochia are a couple of the professors at CACS, the Center for Advanced Computer Studies. I hate these acronyms. I got out of DC 9 months ago. I thought I was going to leave acronyms, but apparently not. They've done a lot of interesting work over CACS on doing things like being able to do the automatic 3D modeling coming out of video streams, being able to stitch together multiple images to create a 3D model as a result of different angles in the same image. We mentioned a couple of others on there as well, the USSD, the SDSU, Extra Frost Optoputer, the Silver Air Patrol, a number of folks in industry, a lot of the ideas of things I already mentioned, HP, Panopticon 3D. We don't know exactly where they're at. We're trying to figure out how to reach out to them. There's not much, so they may be dead, we're not sure, but they've actually done some of this work to take multiple video angles to create a 3D live video as a result of that. Cisco's got some very advanced video analytics going on, et cetera. So that just gives some of the examples. And then to close this up, the benefits of this, some of them are pretty obvious and they line up with a lot of the benefits of the other two public safety projects that have already been mentioned. Better situational awareness of events, being able to actually see every angle of it in as best a way as possible. Early warning and detection of events. If this is a system that's up and running, well then you can have some of these processes running even when there isn't an event going on to be able to be more dynamic in responding to them. Post-event damage assessment. The fourth one, though, is the one I wanted to make sure, the fourth and fifth I think were very very interesting. This is a project that leverages fiber in a very significant way because we're talking about bringing in massive amounts of video. We're talking about analyzing massive amounts of video. We're talking about visualizing massive amounts of video. That's all going to have to be moved around to wherever the appropriate computing resources and talent is. And then we're also, to give you a sense of just how much bandwidth something like this HP Labs Pluribus takes, when I went and checked this out, they're able to use six $1,000 off-the-shelf projectors to create a seamless three-dimensional image. Their ideal is to use uncompressed HD video to pull it off. That's 6 different streams of uncompressed HD video. Their ideal is 20 gigabits per second. And even with compression, we're talking about a gigabit per second. Okay, so we're talking all this video coming in, all this video being analyzed, all this video being visualized, and it's being displayed in a way that's going to truly make use of these networks in that way. We're also excited about it because it provides a variety of different future research paths. Again, I think there's technology that's already been developed within each of these 4 categories, but there's also more work to be done in each of these 4 categories as well. So we wanted to be able to have something where we can get a project started and have it be something that grows out in a variety of different ways, not just in Lafayette, but is pulling in all of you guys, to work together on this. It doesn't have to be our project really in that way. We just want to find something that can really push the envelope in that way, and we think this can do. So with that, that's my contact information. I'm looking forward to meeting many of you later tonight, and thank you all for listening.
Okay, great. Questions for Jeff?
I think they all want to go to the reception.
Well, there's that. Feedback, comments?
Well, actually, can I ask a question of you guys? Sure. Is what I'm proposing feasible? It's kind of science fiction-y a little bit, right? But we built it logically based on trends that we see of various sorts. Is this something that's doable in any way? Do you guys think? Not seeing nods or shakes. That's
So what's the application for the 3D video, right? When I think of 3D video right now, we have a 3D TV already coming out, right? You can buy your 3D video at TV and watch it at home. But what's the application scenario there? Who do you see as a user? Business model actually.
Well, one of the things that I found really interesting in part of what inspired it also when I was visiting the HP Labs was the thing they were pointing out is when you're watching this video in this large screen, in this high quality footage, you're actually noticing things that you wouldn't on a 2-dimensional image. You're noticing things in the back of the room that you wouldn't have seen, that you wouldn't have, it just wouldn't have registered with you in that kind of way. No, definitely no. I'm talking. This is the public safety. I'm imagining there's an event going on. There's a 30-foot screen. There's multiple camera angles on it. Those are all stitched together in some fashion to either provide a series of 3D images or ideally, ultimately, 3D video that you could potentially move the camera around as if it was a 3D animation almost in that kind of way. And so that's definitely the thing that I think is a little more out there. I don't think that necessarily exists today. But again, we did find this Panopticon company. So. All right. Well, I guess that's that. Thank you all for your time.